Okay, when you send me questions, you're going to see two things when I pull up the question. You're going to see this number, and you're going to see this number. I want y'all to make a note of that in your notes. The first number is the number in the book. So if anybody's got a book, turn to 5A in the book and go to the page that has the homework number 19. Okay, that's what the first number is. When I say 5A 19/2, it's 19 in the book. So if you turn to number 19 in the book, well, turn to the homework for 5A. Where's 5A? Okay, there it is. Right here. See the exercises? And go to number 19. Flip the page. Yeah, in the U.S. today, blah, blah, blah. This question will look like that. It will not be the same. It will look like that. This 2 here says that it is your online homework number. So anybody that's printed out your homework and put it in your notebook, go to number 2, and this question will look like number 2 in your online homework. So that's what those 2 numbers are for. So you click on, well, you ain't going to click on it, but I click on it, and that will give us our question that's sent in, and this is basically what I do. Now, I have no idea what this question said because I hadn't looked at it. Okay? A poll, well, there we go. Well, a poll in 1,005 women in a country were asked whether they favor or oppose the use of federal tax dollars to fund medical research using stems of cells from human embryos. Okay? Among the respondents, 47% said that they were in favor. So let's just write down what we got. Okay? So far we've got 1,005 women polled. Okay? Now get your handy dandy calculators out because we're going to do some math here. And it says among the respondents, 47% said they were in favor. Okay, so in favor, I'm going to put 47% right here. And I want you to take your calculator and take 0.47 times 1,005. I don't have any idea what the question is asking. Okay, this is just stuff that I would do at the beginning of the question. So somebody tell me what 0.47 of 1,005 is.
472.35.
472.35. So we're going to say 473 because there's no such thing as a point person. So you always round it up when you're talking about statistics and people. Okay? So that means take 473 away from 1,005. What do you get? 536 or 532?
2.
532. Means what? Not in favor, which should be 53%. Now, there's 2 things I can talk about right here, percentages and complement. All right? The question gave us this right here. Question gave us 47%. Now, percent is a proportion. It's a percent. It's also, in some cases, a probability. But in this case, it's what's given. I took it away from 100%. That's called the complement. So you need to write that down. And you're going to hear it again. Complement is what makes up the whole. You always heard, in the past that behind a good man is a good what? Behind every good man is a good woman. All right? That is an old saying, but You know, if some of y'all go to married, what's it called? When somebody gets married, weddings, thank you. Couldn't think of the word. All right, some of y'all hate weddings. I'm one of them. I can't stand to go to weddings. I used to have to sing at them. I can't stand them. Okay? I hate weddings. I hate funerals and I hate weddings. Okay? Some of y'all, like my ex, loves to go to weddings. Okay? Some of y'all, like, write down a calendar. Okay, this person's getting married. This person's getting married. This person. Oh my gosh, you need a life. Okay? I'm just kidding. I know there's probably not too many of those people, but there's always one or two somewhere. But man and woman together at a wedding that I was raised on, the wedding that I went to when I was a kid and a teenager and everything, was a man and a woman, and they make what? They make two into what? A one, a union, one, okay? So one complements what? The other. Usually it's the woman that complements the man, not many women, men compliment women. But anyway, to make the long story short, they two people that make up a whole. Now I'm using that as a scenario because of the word complement. Complement means what makes up the whole. I always go to another example. And it's good to look at 2 or 3 different examples with complement. And I'm trying to kill 2 birds with 1 stone here. Complement is a very important term in probability and statistics because you use it all the time without even knowing it. Another complement. When I was in junior high school at Southwood in the hood, okay, you bought lunch, and lunch was 65 cents. Okay? Lunch was 65 cents when I was going to school. And I always had $1. My mother and father always gave me $1, and I would take it to school, and I had $1, whichever. And that would leave me with what? 35 cents. So 65 cents was what I paid for lunch. That was given to me, and then what was left was 35 cents. So the complement of 65 cents to $1 is what? 35 cents. Same thing here. You can have a complement with a quantity. This is given. It wasn't given in the sentence. This gives you this. So this is given, therefore, this is given. All right? That's the quantity, but what's the complement of the quantity to this quantity? This. So this is the complement. So you can do a complement with a percentage. You can do a complement with a decimal. You can do a complement with anything. What's the complement of black? What's the complement of black? White. Thank you. What's the complement of true? False. What's the complement of guilty?
Not guilty.
You sure? Or is it innocent?
Depending on what you use the word as.
Exactly. Is OJ innocent? Hail to the no. All right. Why do I say that? Well, I like to talk about this because sometimes we get the word innocent and guilty mixed up when we're talking about compliments. First of all, let's see. Where do you work? Amen. I can't use you. I'm just going to pick on Mr. Lowry. Okay, Mr. Lowry works at Papa John's Pizza. Okay, up somewhere up there in Anderson. Okay, and he works there, and he goes in pretty much every day from 3 to 11. All right, except a couple of days. He's got a roommate. Roommate's named George, and George doesn't work. He's pretty much a slacker. And he lives off of Mr. Lowry's paycheck and bums off of him all the time. So Mr. Lowry works, and one Saturday night or Friday night, he's working. He's getting ready to go work, and George, laying playing video games, says, "I need to borrow your car. I'm going to a party tonight." Okay. Come by, have somebody come by and you can get it while I'm at work and just bring it by before 11. So he goes to work, and he's working, and he parks his car outside, and George has an extra key to it or whatever. And he comes up or gives the key to him or whatever, and gives him the key. And George has the car for about 2 or 3 hours. Well, it's Friday or Saturday night, it's busy, and Mr. Lowry don't think anything of it, and he's working. And he's pretty much like the assistant manager because it's Friday night, the manager's not working. So he's there and he's working. And 11 o'clock rolls around, his car's out there. No problem, he goes home and goes to bed. But what Mr. Lowry don't know is George went out and robbed the Waffle House right down here at West Anderson, okay? Shot it up real good. The place done been robbed like 3 times since it opened at West Anderson. That's why we don't have a Chick-fil-A. That's why we don't have a Publix. That's why we don't have a Wendy's. That's why we don't have, should I go on? Anyway, make a long story short, George robbed it, took the money, and of course, took the car back, whatever the case may be. So his buddies picked him up and took him, blah, blah, blah. Well, of course, the parking lot has a camera on it, and the camera got his car with the license plate, and also the inside got what they wore masks. Okay? Is Mr. Lowry going to go to court? No, he's not. Why? Exactly. If he's got witnesses at work, and what else is in the pizza place? Cameras. All right? He's not going to see a day in the courtroom. And why did OJ? Why did OJ go to court? Somebody tell me. I didn't say jail. I said, why did he go to court? He didn't have what? He didn't have an alibi. Think about how hard it is for you to say that you were somewhere. How hard is that? I mean, there's people everywhere. Unless you're a hermit or living under a rock, most of the time people can verify where you are. How hard is it not to know where you are? I mean, to not have an alibi. How difficult is that? Very difficult. Unless you, like I say, just sit at home and do nothing. Okay? And even then, you might have a camera on the outside of the floodlight. The whole point is, he won't go, he's innocent. That's the difference between not guilty and innocent. He won't go to court. Now, George will go to court, because eventually they'll figure out after his testimony that George borrowed the car. Then they'll start hammering George. George can't prove where he was, because he wasn't at home. He wasn't at work with him. They just see him give the keys to him at 8 o'clock or 8:05 or whatever. So that's the difference between, you go to court, that means they got enough evidence on you to what? You ever seen My Cousin Vinny? They should have never went to court. Okay? Because when they left, the guy was still, it's one of my favorite movies. I love that movie. It's one of my favorites. Okay, I'll shut up. Anyway, now you know the difference between a compliment and, the original. Those are the two. So I'm going to go there. Okay, now, what is the population in the given problem? Choose the correct answer below. Well, it's all women. Okay. All women in the country. These are those type questions that are so easy that you really think they're difficult. All right? All right, the second question. Identify the sample for the given problem. The sample is 1,005 women. All right? What is the population parameter in the given study? The population parameter is usually what is given in the question. Okay? What is given in the question. In other words, somewhere up here. Okay, right here. That's it. So you need to write that down. What's given? Now, if I gave you 500 people out of 1,200 said that they were in the Marlboro Club, then I've just given you not a decimal or a percentage, but I've given you a proportion, which is a 25-cent word for fraction. Okay? So you can either be given a proportion, you can be given a decimal, or you can be given a what? A percentage. And that is a parameter. Okay? Percentage of women said they are in favor. Verify the sample statistic. Choose the correct answer below. what is the sample statistic? What did they give you? They gave you 47% were in favor. So it would be probably D. Okay? So I'm going to hit D, and that would probably be it.
Did you say that the people in favor and not in favor would equal out to the number of
Should be 100%.
100%, which is the quantity, right?
Yes, the 100% is 1,005.
But because you can't do a portion of a person, that would be
I
1,006.
bumped it up. No, see, what I did is I took this away from this, so it wouldn't go over 1,005.
Okay. All right.
Okay, I didn't do 53% of that because then you'd come out with the other and then you get confused.
All right.
That's why.
Okay.
Okay, so there's 3 or 4 things going on here that are real important. One is no difference between a proportion, a decimal, and a percentage. Okay, a proportion is different because you're going to see a difference in the way it's written. It's going to be written in a poll. 1,005 people were tested. Blah 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 blah. Among the respondents, 473 said they were in favor. That would set up a proportion because you have to put it over and over to get the decimal or the fraction. So that's the proportion, and that's what I mean by quantity. All right. So therefore, this is the complement of this quantity given. And then you would take this quantity and change it into a what? A percent or a decimal. Okay? So, and that's how I go over questions. So, do I go over a little bit more? Yes, but this is a kind of a vague chapter because it's kind of fitting a square peg in a round hole and a round peg in a square hole because it's trying to get everybody on the same sheet of music. Unlike chapter 7 or 8 when we go into other things that are more specific. This is kind of like a big pot. Okay, so I'm going to be, when I go over a question that you send me, I'll probably spend a little bit of extra time on some other things that I can pull out of that question. But when we get into Unit 2 and Unit 3, it'll be a little bit more specific. Okay? Hopefully that'll answer your question. That's the only question I got. So, of course, I assume that y'all are understanding Chapter 5 because I think did I go over any Chapter 5? Okay, I didn't. All right. Okay, I'm getting y'all mixed up. Do I get y'all mixed up with 120? Yes. So y'all have to watch out because since we're going over the same material, I get y'all mixed up sometimes, okay? All right. So that's how I go over questions. So as long as you send questions, they go right to this. See this little Math 103 folder? It goes right to there. And then at the beginning of class, I pull up the questions. If there's no questions, I assume that what? You know the material. So today, we're going to go over Chapter 5. Before I start, is there any questions about, besides the loser that can't get in HerMyLab Plus, is there anybody else that's having any trouble? Anybody else got any questions about any of that? Okay.
About getting in?
No, getting in, logging in, anything.
No, but I do have an issue that troubled me last class and this one is.
What's that?
The difference between qualitative and quantitative.
Quantitative, just remember, quantitative is quantity.
Yeah,
Remember?
It's a little odd, like,
Well, give me an example.
Saying a person's rank in the military.
That would be quantitative because you cannot put a number value on it. People say E8. Well, E8 is not a number value. It's a level, okay? It's not a number value.
Okay.
Such as $20 bill.
Right.
Does a $20 bill have value? Yes, it has value monetarily and it has number value, okay? When you have number value, you're talking about quantity, okay? Qualitative is when you're talking about a characteristic. A characteristic would be an E8 or a rank in the military. That would be quantitative. All right. Now, if you count the number of sergeants or number of whatever in the
Or height of a tree or something.
height of a tree, yes, height of a tree, yeah, that would be quantitative. Anything having to do with counting or measuring is quantitative. Okay. Just remember widgets in a company. Just remember that. Or eggs in a carton. That's quantitative. I mean, qualitative. Quantitative, sorry. Qualitative would be how many blondes, brunettes, and redheads are in the class. Hey, no, we got 2. I've never had 2 before. 2 redheads. Usually we just have 1 or less than 1. Okay? All right. So everybody good there? Let's get to the questions. Or let's get to the sections. I'll go over this section. Go over it pretty quick because, like I said, chapter 5 is a lot of terminology. Okay, where is my, there it is. My courses, let's go to chapter contents 5. What did I go over? And let's look at the outline. 5, A, C, and E. Or do I go over all of them? A, C, and E? Okay. So we'll go over A, C, and E. And what I'll do is I'll just go down the book and pull out the stuff that you need to know versus what doesn't really matter. Okay?
Class schedule been adjusted because of missing days.
Yeah, but it's basically just been put off. Versus some of your, do you have any instructors that actually tell you to go out and fill out the dates of the outline? Do you even have any of those instructors? Because I don't do it. Anybody? Okay, well then you don't have to worry about it then. It's the ones that, what they're talking about is the ones that go through and say, okay, I need everybody to put a date beside each one of these sections. And I'm not doing that because
material that we missed into other classes.
No, basically we're going to have time for that because there's 10 or 11 classes that you don't have to take a test in here or all that. So we got plenty of time. And plus I don't go over the last unit anyway because I don't think it's that important for you to go into another class. Anyway, we'll be all right. All right. First thing I want you to do is if you've got a book, get a highlighter out. If you don't have a book, then you need to write down whatever I go over, and this is your first thing that you need to talk about. The 2 different definitions of the word statistic. Okay? The 2 different definitions of the word statistic. When you're talking about a capital S, you're talking about the obtaining, organization, calculation, and interpretation of data. That's it. Okay? And that's what it says right there. Collecting, organizing, calculating, interpreting. That's the 4 words you need to know of data. So if I go out here and I ask everybody in the parking lot if they own a car or a truck. Okay, then I have gone out there and I have obtained data. Now, what I do with that data is also statistics with a capital S. Lowercase s means parameter. I can't spell. Parameter, and I got stuff in the way. Parameter of the sample. Okay, parameter of the sample. I don't know what they have. Okay, I disagree with that definition. Okay, because most of the time when you walk in, let me go ahead and tell you this. I might have told you this. This book sucks. Okay, did I tell you that? If I didn't, it does. All right. One of the reasons we have 103 to this day is because people couldn't pass Math 220, which is the second statistics course. And we're not talking about Tri-County students couldn't pass it. We're talking about Clemson University students couldn't pass it. So instead of raising the bar for their students, they basically watered down another math course and called it 103. Okay. Now back then, 5 or 6 years ago, the Math 103 was like boom, boom, boom. Everybody had to take it at Clemson. All right. But now we really don't use it for much. Some use it at Clemson now, but now it's taken as another math for a lot of nursing students. Okay. So that's why we have it. Anyway, when the book was written by a former colleague of mine and a former teacher of mine. Both of them sucked, okay, as far as teaching goes. But what they did is they went through and they took normal terms in mathematics and dummied them down because they thought the students basically would do better, okay? And this is one example. When I teach the 103 course as far as probability and statistics, I teach it like you're going into another legitimate probability and statistics course. So I change a lot of the stuff that they teach because I don't want you to be blindsided by a term that you should have learned, but you didn't because the book is dumbing down. You see what I'm saying? Okay, well, if you don't. A statistic is a parameter of the sample. A statistic is usually written in terms of letters, like X bar for the mean and S for the standard deviation. Now, why do you need to know it? Is it beneficial for you to pass this class? No. The main reason you need to know the difference between a parameter and a statistic is because, let me change this word, variable. Okay. The reason you need to know that is because if you're in a meeting, let's say you work at AMED, what's your last name?
Hayes.
Hey, Miss Hayes works at AMED. And in AMED, you have a department meeting, okay? And whatever department she works in or whatever, to north or whatever the case may be, they have a meeting. And in that meeting, there's one person that is in charge of quality assurance for that division or that department, okay? So if True North lost too many, where are you working in AMED?
The neuro unit.
Neuro unit. So let's say too many people died in that unit last year. Okay, well, this quality assurance person would come in and say, okay, let's look at the last 5 years and let's look at the last year. Okay, and they look at last year and they say, boom, 25% increase of people dying in this unit. Okay, well, they will throw out these numbers and they'll say, okay, well, the last 5 years, X bar is equal to blah, blah, blah. Well, what they're saying is, when they say X bar, that means the sample that was taken. So you're saying in your mind as a student or a person taking this information in, you're saying, okay, that's the sample mean and the sample's the standard deviation. So that means the few people that they actually surveyed or they actually whatever, that was the sample, it wasn't the population. And it's a knowledge thing for you to know. That's why we learned this. That we learned the difference between a sample statistic and a parameter, a population parameter. A population parameter, let's write that down. A parameter is a variable. Parameter is a variable in the population. And it is usually given by Greek letters. Meaning, mu is equal to the mean, and sigma is equal to the standard deviation. So let's say that they took I don't know what attrition, that's what you call it in academics, but fatality, is that what it is in health? Fatality, where people die. Okay? Fatality count of the last 5 years, and they used the fatality count in 2017 as a sample. Okay, whatever. Then they're going to throw up mu, and you're going to know that that's the mean of the last 5 years without them saying that, because you know that mu, it's pronounced M-E-W, it is a parameter for the population, which population is always your largest what? Your largest body. A population parameter. Remember, population parameter, P and P. Population. The population is always your largest body. It's what you're predicting. Okay? The sample is always your smallest. The sample is what's used to predict for the what? For the population. The sample predicts for the what? The population. Now, why do we use the sample to predict for the population? To save two of the most valuable things that we consider valuable. What is that? Okay. I'm going to have to do the enunciation speech in here. When you walk up to somebody's door and you knock on their door, do you do this?
No.
I hope the hell not. Okay? Because that just irritates me when somebody does that. You walk up to a door, you knock on it. So if you're going to answer a question in my class, I want you to do two things. I want you to enunciate, and I want you to have volume. None of this. Okay, that just irritates me. Spit it out there. I'm not going to embarrass you. I'm not going to say you're stupid or anything. Okay, now I'm going to ask again. What do we say to the two most valuable things in our lives? What do we say when we use the sample to predict for the population? Two of the most, I don't care what profession you're in, I don't care how old you are, they're the two most valuable things that you have. One starts with a T, the other starts with an M. Thank you. Time and money. What does everything revolve around? Time and what? Money. Now, I'm not talking a materialistic person. I'm talking a business. Most of y'all are going to be in the real world in the future, if you're not in the real world now. All right? When you get out of academia, you're going to the real world. And you'll have to deal with those two things, time and money. The sample, you use a smaller group. You get the information from the smaller group. You run it through the statistics. You run it through the probability. You run it through the confidence levels. And then you spit out a prediction for the population. Example. Let's say you work at Michelin. I always use Michelin because it's just the best way for me to think about it. And let's say you're the quality assurance manager for this whole Southeast Division. You work up there at the Crystal Palace up there where California Dreaming, I don't know if it's still up there or not, but near up there between Greenville and Greer or Greenville and Spartanburg. Y'all know where I'm talking about? That big old Crystal Palace got Michelin on the side of it? Okay. Anyway, you work there, that means you're making pretty good money. And you're the quality assurance manager for the Southeast, which means I don't know how many Michelins there are, but I only know two. Sandy Springs and Anderson right over here. I'm sorry, Star. Okay? I had to extend the line to get it in to help the school district out, which is fine. But anyway, make a long story short, you're in charge of those two plants. And every year you have a meeting, and that meeting is at the end of the fiscal year, and you project numbers for the next year so you can budget money for the next year, right? Now, we're not talking about department heads. We're talking about executives. You are the quality assurance executive for the Southeast. So you take care of any Michelin plant, anything that has Michelin on it. I think there's something over in Greenville. Donaldson Center, right? What is it?
I just know that they did that same thing.
Is it as big as these two?
About the size of Anderson.
Oh, I didn't know that.
Yeah, my dad works up there.
Oh, okay. Anyway, there's three, so there's probably 6 or 7 more in the Southeast. I have no idea. But you make 6 figures, okay? You make 6 figures. And you walk into the meeting, and, okay, next week, we want everybody to prepare their reports for 2019, whatever the case may be. And you go so you got 7 days, and you go to the plants, and you meet with their quality assurance managers. And you say, okay, we need to pull some tires. We need to pull these tires and see if they're good or not. And the manager says, how many you want to pull? Listen, I got a week, just pull 5. Okay? And he pulls 5, and he pulls 5 to all the stations. And he presents, and a week later, he takes 5 tires from each one. And he said, look, I predict next year in 2018, he tells the president and the CEOs and everything, he says, I predict we're going to have about a 65% chance of, I'm sorry, a 25% chance that we're going to have bad tires coming out of these plants. So they go, okay, 25%, they write that down. Then they take that 25% and multiply it by however much money they got toward bad tires. And they come out with some big million number. Everybody with me? Okay. Next year comes around. And they have the meeting before they present. And they say, okay, we need another bid, but there's a problem. Our defective tires was 75% of each plant. We had something go wrong or something, I don't know what the case may be. But the price was higher than what? Than you told us. So guess what happened? You get fired. Okay, because we're not talking about $5 stuff here. We're talking about what? Millions. And you're getting paid 6 figures. You were being lazy. Okay? You should have pulled 500 tires instead of what? 5. Or 150 tires instead of 5. All right? So that's how these things can be used. Instead of pulling, I don't know how much a Michelin plant makes, 500,000 tires a year. Instead of pulling the 500,000 tires, you pull 5,000 or you pull 500 as a sample. And you know, when I was growing up in the dairy business, my father had a dairy farm and we milked 250 Holsteins day in, day out, morning and night. The man would come by from the government milk testing, whoever, USDA, and he would come in and he would, each cow we would milk, he would open up the little window on the side of the milker and he'd pour a little bag in the little, looks like a sandwich bag only. You ever had retainers and you had these little rubber band bag about like that with a Ziploc on it? He'd put it on there, he'd put the cow and he'd put the number and how old she was and all that, the tag number, tattoo and all that. Why? He was pulling a what? A sample. Okay? Therefore, if there's any bad milk in there, then he would come knocking on our door and say, look, we've got a problem. Pulling a sample to predict the population, which was that farm. The population was that farm. Okay? So that's the difference. Now, again, I kind of went over several things off of this one, so I'm probably going to skip the next part where it says population. It's probably going to say population or something like that. So I'm probably skip that. Now remember, I'm teaching to the person that's never had this before, so hopefully some of you that have had like 5 or 6 probability classes, I'm sorry, but there it is. Population and population what? Parameter. Parameter is a 25-cent word for variable. We get a lot of 25-cent words in mathematics. I think that stems from the math geek trying to be bigger than he is. That's why mathematics has so many big words, trying to impress people. Representative sample, we just talked about that. I'm not going to go in that. Okay, let's talk about a simple random sample and a random sample. A random sample. And this is a word that you will see on a lot of standardized tests. What is a random sample? Now, they don't have random sample, and some books will make a difference between a random sample and a simple random sample. So I'm going to give you the definition as if you were going into a probability and statistics course. Let's say I wanted a random sample of people in here, blah, blah, blah. And I took everybody's name. I took one of these Post-it notes right here. The reason I'm showing you the Post-it notes is not to take up time, but there's a reason I'm showing you the Post-it note. I'll pick these. I have no idea where these Post-it notes come from. I don't know whose they are. But here's the Post-it notes. They're all what? What color? Pink. All right? They're all pink. And I tell you to take a pencil. Nobody use a pen. Nobody use a marker. To take a pencil that writes lead and put your first name, middle initial, and last name on this Post-it note and fold it in half. Now, there's 3 or 4 things I've already done to make sure of what? I'm talking about.
It's random.
It's random. In other words, no bias. Okay, what did I do? Name the three things that I did.
Color's the same.
The color is the same.
The writing is the same.
The writing is the same. It all comes from a lead pencil.
And the fold.
And the folding is the same. Those are all three things of uniformity, which uniformity takes away bias. A lot of people say, well, what do you mean bias? You don't know any of us. No. So what I'm talking about. If you reach into the fishbowl and you feel one that's folded different, you might what? You might pick it. That's why. Okay? So, write these things down. These are things that fight uniformity, fight bias. All right, I give this, and y'all write your names on it. I take it up and I put it in a fishbowl. Everybody folds it in half and puts it in a fishbowl. And somebody picks it. That's called a random sample because why? 3 or 4 words. Everybody has the what? Equal chance. Write that down because that's the key words. Everybody, and that's what you meant by random. Everybody has, and the key word is equal. Now, being one of the redheads of the group, your last name?
Harvey.
Miss Harvey decides that she wants to be a little bit different. So she folds hers in quarters. Is it still a random sample? No, it's not. Let's say that Mr. Lowry, let's say that the reason I call on people, I'm trying to learn your names. That's why. Because I suck at names. I really do. That's one of my weaknesses as a teacher. I suck at names, and I can't remember names, so I'm trying to remember your names. Okay, Mr. Lowry, he decides, oh, he came in late, of course, and he came in late, and he don't know what day it is, so he just grabs a piece of paper, and he just takes a piece of notebook paper and writes his name off, tears it off, puts it in. Is it a random sample? No, it's different. Anything that persuades the drawing to be different takes away the random sample. If everything is uniform, if everything is non-biased in the same way, same format, it's a random sample. What's the difference between a simple random sample? A simple random sample is basically groups. Let's say I take this group over here, these 4 people right here, and I call them Group A. And I take these 4 people and I call them Group B. And I take these 3 people and call them Group C. And then I say, okay, here's a pink Post-it note. Here's a pink Post-it note. Here's a pink Post-it note. And you write Group A, Group B, and Group C in it, and I put those 3 in a fishbowl. That's a simple random sample. What's the difference? Individuality versus what? Group. Okay, now that is the way I was taught, simple random sample versus random sample, and that's the way I teach it. So, write that down. Simple random usually has to do with a group. Each group has the same what? Equal chance. Convenient sample. Convenient sample is the least used. Why? Because it's the most what? Why do you think it's called convenient sample? Thank you. You know, I'm cueing y'all to give me interaction, okay? Some of y'all's going over your head or what? I don't know what it is. When I ask you a question, I want you to answer it. All right. I work at WHUB Rock 102.6. Okay? I'm a DJ. And I play all 80s hard rock, which is the best rock there is next to the 60s. Okay? Because the 90s and the 2000s, I'm sorry, but they sucked. They were all emotional and all this, and they really sucked. Anyway, so the 80s was the best, so that's what I play. That's what I play at the radio station. I decide that I'm going to send out a survey across the radio waves, and I'm going to say, how many of you like rock music? Call in now. Why is that an inaccurate sampling?
Everybody that listens to it obviously likes it.
Everybody that's listening to me likes what? rock. So that's a sample of a convenience sample. Why is it least accurate? Because it's what? Most convenient. Convenient sample, convenient. It'd be like you working at a convenience store and asking how many people in there smoke. Customers smoke. Well, a good proportion of the people that come by a convenience store usually get a pack of what? Cigarettes. Okay, so that would be a convenient sample. Now, what if you were working at QT? I pick on QT because that's kind of like the Target of department stores. You go there because it's nice and people, got most of their teeth in their head and, they got good sense and it works out real well, okay? And when you use the restroom, you don't worry about catching something, all right? I'm sorry, but I got a thing against cleanliness in a public place, okay? If you're going to sell to the public, you need to be clean, okay? And not stink and not be dirty. I just can't stand walking. If I walk into a convenience store or a store and it's dirty and I can see it, once I walk in, I leave. I turn around and I walk out. That's just me. But I could be strange. But QT, you work at QT, but you hand out a form and tell people, look, if you would take this and fill it out. Of course, QT wouldn't let you do this. But I want you to tell me if you're on a diet or not. Or you eat healthy, or you could put anything you want to on it that doesn't pertain to QT directly. Okay? Why, some of you might say, well, you're going to get junk food. You ain't been at a QT lately, have you? What do they sell besides junk food? They sell fruit, they sell salads, they sell water. They sell stuff that you can actually go in and get and not eat junk food. Okay? So you could actually ask about health food. I mean, they don't have chia seeds or anything like that, but they do have salads, they do have rabbit food, they have, things that you can eat if you're looking for that. Okay. Name something else. Well, your weight or your age. Let's go with age, okay? That could be asked. Now, would that be a convenient sample? Yes. Would it be biased? No. Because who doesn't stop in QT? Or who doesn't stop at a convenience store? Okay? So that would be something. So sometimes convenience sample can be accurate as long as you pick your what? Subject. Okay? Picking a subject like you in the Marlboro Club, that would probably not be a good subject to pick if you worked in a convenience store, especially if you worked in one that, you go into some convenience stores and they have like some drinks and some candy bars, but the rest is cigarettes. It's got a whole wall of cigarettes. You know what I'm saying? Then that would probably not be that would be a biased convenience sample. Now, this brings to question. If you are going to be using statistics in your job, or if you are going to be subjected to statistics and probability via a meeting, a department meeting, should you take these things into effect? Yes. Because it can give you what we call a biased outcome. Okay? There's an old saying about statistics, I never can remember it, but basically the only thing about statisticians is you got to watch it because sometimes they'll make whatever they want presentable. In other words, they make the outcome come out to what they want it to be. Okay? That's what all of you as students, as employees have to watch out for whenever you're subjected to probability and statistics. Now, I'm going to tell you, I get one student every semester that complains that I talk about politics. Well, it would just come off of a what? A presidential what? Okay, that's what I don't know about other teachers, but statistic teachers, they can't help but talk about politics because what is usually dominating in politics? Polls. And you can't talk about statistics and probability and not talk about polls. But I like to use polls as an example for bias. Okay? let's say I'm a pollster and I own my own polling company and I live in Washington, D.C. and I make all this money making polls because that's what a lot of them do. All right? So I go up there and I make this poll and I say, I have got this poll that I know is accurate because I've went across the United States and I've asked this question, who's going to be the next president, Smith or Jones? And Smith is conservative, Jones is, I have to use different names because if I use the real names, I get fussed at. Somebody gets offended. Anyway, Smith and Jones. And I go across the United States, and I come out, and Jones wins by 57%. And everybody goes, God, I don't understand that. Everybody's supposed to be voting for Smith or the other guy because he's not conservative. All right? Kind of like what happened in 2016. I'm sorry. Anyway, the whole point is, I went from South Carolina to Georgia, to Mississippi, to Alabama, to Louisiana, to Texas, New Mexico, Arizona, and southern part of California. Did I cover the United States? Did I go across the United States like I claimed? No. Yes, I did. You tell me I didn't physically walk across the United States?
Different regions of the country, though, vote differently.
Exactly, but did I walk across the United States?
You went from one coast to the other coast.
Did I go from one coast to the other coast?
Yes.
My claim was that I went across the United States. Did I do that? No. But you caught what I was emailing. The problem is a lot of people don't catch it. Okay? A lot of people don't catch it. Now I'm going to talk about this election because I caught it and I brought it up to other people. There was when there was 18 presidential candidates on the Republican side, it was 18 or 17, something like 17 or 18. Well, of course, the media didn't have their votes because they can't stand Republicans, but there was a Republican favorite, all right? And then there was a Republican second favorite. Can anybody name the first favorite? Jeb Bush. That was the first favorite. The second favorite, least favorite, was Cruz. Okay? Well, about 3 or 4 months into the election, or the Republican election, Bush, they could tell that Bush was not going to be the Republican nominee because he couldn't even get 2%. Okay? Now, if your person is Bush, I'm sorry, that's the mathematics. He couldn't get 2 or 3%. And he was spending millions and millions of dollars, more than any other candidate, and he could only get 2%. Nobody wanted him. Okay? So they turned to Cruz. Okay? Because nobody wanted Trump. Nobody. And right before the first debate, there was a poll that came out like midnight. All right? Came out midnight, and it said 57% of the people polled says that Cruz is going to be the next presidential candidate. And down at the bottom, N is equal to 101, and margin of error is plus or negative 7%. Okay? I saw that poll, and I was all over Facebook. I was all over Facebook saying, this is BS, this is BS, this is BS. Why? 2 reasons.
Yeah.
Say again?
There wasn't that many people.
100 people in a poll? I might as well just poll y'all, because 30 and 100 in probability is the same thing. How many should I poll? 500? 1,000? Yes. What else? Margin of error should always be 3 or less, because nobody's what? Perfect. Okay? Most of y'all are going to make a 98 or 99 or 97 on a test. How many of you are going to make 100? Not many, unless you have 3 tries. Okay? But not many are going to make 100 first what? Shot. All right? So 97, 98, 99, that's 1%, 2%, 3%. So I was all over Facebook. Look at the MOE mode. MOE and N is insufficient data. Why did I bring that up? Because the wheels of the Republican Party were already turning to go against who? Trump. They were already turning because Jeb Bush, he just fizzled away. So they had to do something. And what they were doing was they were trying to build up Ted Cruz. and they were falsifying, and basically they were falsifying a poll and calling it a poll when it was basically a survey. You can't go on national TV, and I'm saying this, and people have to watch things like that. Okay? Now that's one example, and I'm not going to talk about it anymore because I don't want anybody to fuss at me. All right? But you've got to watch bias. And that's what convenience sample sometimes, and it's very important. Systematic. Systematic next to random sample is probably your best bet. Now, why would you not want to use a random sample? Because of time and what? Money. Think of the number of people in the phone book. We'll just go with Anderson County, okay? Anderson County. I don't know if somebody can Google it, but how many we got in Anderson County? Does anybody know? I have no earthly idea. Somebody Google it and tell me. But the whole point is, let's say every one of those people are in the phone book. Are you going to send out 500,000 surveys? Anybody got it? How many people are in Anderson County? Oh, come on, some of y'all don't.
194,692.
Okay, 200,000.
2015.
Okay, 200,000. We've had some babies since then. All right, let's say 200,000. Are you going to send out 200,000 emails because you want a random sample? Or are you going to send out every 100th person in the phone book? So what you're doing is you're making a random sample a little bit smaller. Okay? Now, a lot of people say, well, golly, that would be 2,000 instead of 200,000. Yeah, but that saves you time and money. And it's still a random sample because you're picking every 100th person. Okay, so those are your two most used, is the systematic and the random. What about stratified? Well, it's okay, but that's when you're talking about grouping. Let me give you an example of stratified. That would be going to a voting precinct and asking people what they did when who they voted for when they left. Okay, because who's going to be at a voting precinct? Republicans and what? Democrats. There may be 5 or 6 independents in there and 5 or 6 libertarians, but majority, there's going to be Republican and what? 2 groups, Republican and Democrat. Personally, I wish there was 10 parties, and I wish they were evenly distributed. That's my own opinion. I'm a little bit of a libertarian/conservative because I believe that there's some things we've lost as far as liberty and some things we've lost as far as conservatism. I'm not a left-wing nut job, and I'm not a right-wing nut job either. And the left-wing nut jobs, they won't give up the same way. The right-wing nut jobs, they're about racist, and I don't care about either one of them. So, stratified is grouping, all right? Next, let's see what we got next. Oops. Damn Russians. That's what when something don't go your way or something don't work or you fail at something, you blame who? The Russians. Or you blame Bush. Whichever one you can say quickest. Here's some examples of whatever I just said. The sampling, sorry. Systematic or simple random, there's the phone book right there, but I don't use it. Yeah, that would be every phone book, period. Every name in the phone book, that would be random. Systematic would be picking every 100th person. Stratified would be groups. You could say male and female if you wanted to. And there's the convenience. Okay. Like I said, this is a lot of vocabulary, and that's why I don't think I could be an English teacher or a history teacher because I talk too much. So I know I couldn't be one. And I don't know why this thing keeps going to the highlighter when I keep picking mouse. Okay? Next. Nah, not worried about that. Let's see what else is down there. Observational. Make sure you make a note of that. This is also a term that you need to know for future classes. Who am I talking about? Well, let's say you're a nursing student, you go into nursing, and then you go into psychology later on. Psychology is eat up with statistics courses, okay? At least 4 or 5 statistics courses. Either they're called statistics, or they're called probability, or they're called research, either one. And some of you that go on to get your master's and doctorate, and eventually will have to do research classes, okay? The whole point is you need to know the difference between an observational study and an experimental study. Observational, I'll give you a prime example of observational. You ever seen these videos on YouTube where people are sleeping, they got sleep apnea, and the people are recording them sleeping? You all ever seen that? They're funny because these people like do weird stuff like possess stuff, or when they're sleeping, and they got these things wired up to them. They be doing convulsions and flipping around and be doing all kinds of stuff. Well, anyway, that's observational study. Why is it observational? You're perving on somebody while they're sleeping, okay? You're watching them, okay? Some people like to watch people. I love to watch people, okay? I could sit at the mall. I don't go to the mall because that irritates me. I could sit in the parking lot out there and just in my truck and just watch people. I just think it's hilarious. But that's observation. A good example of observation is counting cars. Okay? When I was in civil engineering at Clemson, well, I was in a transportation course, and they told us to go out and count cars. Pick a road, tell me what kind of road it is, and how many cars travel on that road in a day. Of course, you'd go out there for an hour. You would count how many an hour, and then you multiply that by 12, and maybe half of that by 12. Why? Because not many people travel at night, especially between 12 and 5 o'clock. So you have to throw in a little bit of, but anyway. So we came up with 2,502 cars, okay? That's called an observation. Go out and you count cars, all right? That's an observation. Observation means you do not have any input or output toward the observation or toward the experiment or study. Versus an experiment. Let me give you another example of observation. How about a mouse in a maze? Is that an observation or is that an experiment?
It's an experiment.
Actually, it's an observation. Why? Because what do?
Just watching it.
You just sit there and watch it, and you what? You time it. Now, I think what you're thinking of is when you put a piece of cheese in the maze.
Well, mice don't just live in mazes.
No, the whole point is to run through and get to the... Huh?
It's not out in the field. Somebody's stuck in a maze.
Well, they're tunnels. What are their tunnels?
That's not what we're talking about.
But I'm telling you, if you put a mouse in a maze, that is an observation. Okay? The experiment comes when you put a piece of cheese in it, or you put 2 pieces of cheese in it. What have you done to the study to make it from observational to experimental? You've inputted something. You've interjected something. Example. Let's say that we're doing the sleep apnea. We said that was observational. What if I give you a sleeping pill? Then it becomes a what? An experiment. Okay? Experiment is when some outside or external input is coming in. Okay? So make sure you know that. And you could say, here's the key word right here. What? Apply. Apply means that you're doing something. You're applying something to it. You're putting something in it. Okay? Next page. Oops. I'm trying, people. I don't go into treatment group and control group, but you can read it. Do not receive the treatment versus someone who does receive the treatment. Group A, they ate good. They were in a room for 3 months, and they ate nothing but vegetables and lean meat and water. Versus somebody we gave a diet pill, and they ate lean meat, vegetables, and water. Okay? Group A is a control group. They were not given anything. Okay, they were just giving food. You have to give people food, okay? You have to. All right, you can't sit them in there and starve them to death. All right, so they were giving food. The same group the group B was given the same food, but they were given a diet pill. And that diet pill makes that group B a treatment group. And that's the only thing you need to know between those two. Okay? Notice it says right here, to be selected randomly and treated what? Alike. That's why I didn't give them junk food. I gave them the same food as group A, the control group. Now, you got to think about this. When you're doing stuff like this, and when you are listening to somebody that present what they did to do stuff like this, you have to think about stuff like this. You cannot say, oh, I'll do whatever they want to. Then you'd just be doing stuff. You wouldn't be doing statistics. You wouldn't be doing probability. You would be doing stuff. Okay? So that's the difference. And it's kind of nice to be educated about stuff like this instead of just going into a meeting or going into a presentation not knowing Adam's house cat, what's going on. And that's basically what this class is for. I don't think any of you will probably go on and be mathematicians, but I hope, more power to you. Most of the time, 90% of the students that take this class or a probability class, most of the time they never see it unless it's in a meeting or a presentation. And that's basically what it's for. Write down the placebo effect. I'm not going to go into this because most of you know what a placebo is. What is a placebo? Sugar. It's a sugar pill. The best example of a sugar pill is Emma Watson on Andy Griffith's show. Okay? And I'll go down the rundown because I'm an Andy Griffith fanatic. Okay? You go in my office, I got the trivia cards, the trivia games, the trivia books. I got the episodes. Anyway, this is like the third episode that they created. Emma Watson was a little old lady, and I'm going to go through this right quick. She picked up a bottle of pills at the pharmacy every week or every month. She picked them up, and they were a dime. Okay? And if you talk to Emma Watson, she was kind of like my ex-mother-in-law. You didn't ask her what? How she was. You don't ask, oh no. You just say hello. Okay, you ever met a person like that? My ex-mother-in-law was like that. Okay? You said hello, and that was it. Because if you say, how you doing? Oh, I worked 72 hours yesterday at work. I got the China flu. I got the, what other flu is there? The Chinese flu, the influenza flu, and the flu that kills you in 3 days, Nile virus, and I've had all that. I've had that for a week. My back's out. My ankle's busted, and I got a headache. Okay. Why don't you just go ahead and end your life, okay? Good gosh. Anyway, the whole point is, she was like that. Okay? So, Fred, the pharmacist guy's been there for 115 years. He had to leave for a vacation or something, and he let his niece come in, Ellie Walker, let her come in and fill in for a week. Well, here comes Emma Watson. I want the pills. She didn't give it to him because she didn't have a prescription. Oh my gosh, Emma Watson's going to die. Throughout the whole episode, the town's worried about Emma Watson. Okay? They're bringing her food. They're bringing her turkeys. They're bringing her chickens. They're bringing her all kinds of food. Macaroni pie, all this stuff. And she's eating it up like a hog, okay? She says, I'm going to die. I only got a few days left. Well, meanwhile, the new pharmacist calls her uncle and finds out what the deal was. And that's why she only paid a dime, and that's why she didn't have a prescription, because it was a bottle of what? Sugar pills. She brought it over her last dying day. She was on her deathbed, gave her a pill, gave her two. So here, take two since you haven't had them in long. And she perked up and started running around, She was fine. That's a sugar pill. All right? I'll give you one other good example, and I've told every one of mine. When I was stationed in Camp Pendleton, got 3 newbies in. They were right out of Parris Island. And they wanted to go out and get drunk. Okay? Well, they were newbies, and we were the NCOs, so we didn't want to get in trouble. So we had a party and got 2, 3 hotel rooms together. That's the way we did things back then. And we had a big old, one tub for bathing in, the other 2 tubs are coolers, okay? So we filled them full of ice, and and this is back when O'Doul's just came out. Okay, what is O'Doul's?
Non-alcoholic.
Non-alcoholic beer. So we filled their room up with a tap. We filled the bathtub up with a keg, okay, and put ice around it and everything. And we took off O'Doul's tap. Okay, we took it off and we put Budweiser or some other brand name that was alcoholic. They passed out by 12 o'clock. They didn't have an ounce of alcohol in them. Not 1 ounce. They passed out by 12 o'clock. Now that was before non-alcoholic beer was actually, they didn't know about it until they were just 17, 18 years old or 18, 19 years old. They just got out of boot camp. They didn't know any better. And all they wanted to do was get drunk. They got drunk, started acting drunk, started falling down. In fact, they passed out. They didn't have alcohol in their system. Placebo effect. Okay? Anybody got any other examples of placebo effect? Those are the two best examples I can think of. It's all what? Psychological. What time is it, y'all? Is it time for class to be over? All right, we'll stop there. Anybody have any questions so far? So I see right now, you are, I don't know, where are we still on 5.A or whatever? Is that what we're on? So right now, y'all need to be working on what? 5A.